So all these four structure, if we are visualizing over here, so they are giving rise to. Hello everyone, welcome back to PLUTUS STEM. So today we are going to discuss a very important sub-part of isomerism, that is conformational isomerism, in which we are going to deal with the conformational analysis of butane. So we have already discussed what is conformational isomers, and we have differentiated between the conformational isomerism and the configurational isomerism. And we have taken a simple example of propane and you can say ethane, and we have discussed their conformational isomers. Over there we have seen that staggered form and eclipsed form, two type of form we have seen over here there, and we have seen that staggered form was more stable as compared to the eclipsed form, and the energy of eclipsed form was far more than the you can say staggered form. So today we will be seeing regarding this conformational analysis of butane molecule, how this butane molecule, the rotation around a single bond will give us a different isomers, or you can say conformers or protamers. So this is our CH3, CH2, CS2, CS3. This is methane, ethane, propane, butane. And in the same way, now again I am going to draw it like this. CS3, carbon number 1 and carbon number 2. It is not the IUPAC naming, be cautious about that. Just to make it convenient for you, I am just drawing this like this. Okay. So over here you can see this CS3 is over here, A, and this CS3 over here is, let's say, B, at carbon number 2. So now if we are trying to draw it in a Newman projection, this is our, if I am visualizing from here the carbon 1, let's say this is our carbon 1, like this, hydrogen at this side, and one more hydrogen, and this side, and in the back side we are going to have another carbon, this one. So these 3 hydrogen are going to be there. So if you visualize these hydrogen, and CS3, this one CS3, and in this side also we were having this CS3 like this. So this is the our methane, now we can say 1 carbon, 2 carbon, 3rd carbon back side, and 4th carbon. If we number it like this, 1, 2, 3, 4. So this is our butane molecule, and we have drawn its structure in a Newman projection. So as I have told you in the previous lecture, that in the previous video regarding the rotation around a single bond giving us a different conformers. So we will visualize over here. So generally we have a rotation around 60 degree. This is our hydrogen CS3. These are our you can say butane molecule, and if we try to rotate it, these hydrogen we are going to rotate now back side 60 degree angle. So what we are going to see over here, we will see with a 60 degree rotation, we are going to visualize over here. These upper hydrogen are like this only, they are constant over here, but when you see the below hydrogen, this is going to come over here, this hydrogen will come over here, and this CS3, because at this place CS3 is there, so over here we are going to get CS3, at this place hydrogen, and this CS3 which was below the side remain over here only. So this is structure and this is structure. So now if we try to rotate again with a 60 degree angle, again 60 degree angle, if I am rotating this compound, so we are going to get structure like this, hydrogen, CS3, they are constant. Now it will move 60-degree rotation, it will move over here. At a 60-degree rotation, it will move like this. So this CS3 will come at this place. This hydrogen will come at this side, and this hydrogen will come at this side. So we can visualize over here the difference between all these three structures are different. Earlier, the CS3 was at the back side of the CS3. Here, CS3 was, you can say, is the neighboring position or dihedral angle. They are neighbor of each other. And over here, we can see CS3 is below side of the hydrogen, like this. This is CS3 and this one is hydrogen at the back side of. So earlier, CS3 was at the back side of CS3 only. But now we are seeing CS3 and the back side we are having hydrogen. So this is the way. Now three different type of structure we are visualizing over here. Earlier in the case of propane and you can say ethane, we were having only two possibilities. One was the eclipse and another was the staggered conformation. Over here we have seen only these three possibility. Can we have some more possibility if we try to draw this some more rotation if we are trying over here? So what we are going to see over here at a 60-degree rotation, this will be like this. So and this bond is going to become over here. This hydrogen will come over here and this CS3 will come at this place. This one is constant all the time. So now if you visualize over here, this one and this one. This CS3 was over here. Now this CS3 moves at this side and in this carbon, this cannot be come over here. This will come at this side. I will show you how. Because this CS3 is rotating. Okay, sorry. This CS3 is going to rotate from here and it will come at this side. And this hydrogen will rotate and it will come at this side. So now we can see both the CS3, they are on the opposite to each other. Both the CS3, they are opposite to each other. So 1, 2, 3, 4. And if we try some more possibilities, so if I skip some more new angle, so what will happen? This CS3 will come at this side. Hydrogen, hydrogen, CS3, CS3, hydrogen and hydrogen. So if you see and this structure and this structure, they are quite same. CS3 below side hydrogen and CS3 below side hydrogen, only the position is changing. So these two are, you can say, quite same molecule only. And if we again rotate this one, hydrogen, hydrogen and CS3, so this CS3 will come at this side, hydrogen at this side. So now this one and this one, they are again same. So again further rotation, we will get the same product like this. So in this you can see I have drawn this 1, 2, 3, 4, 5, 6 possibility from where these two can be neglected because these two are similar, you can say structure only. These two are similar structure only. 60-degree rotation, 60-degree rotation. So if you see over here, visualize that we are having four different structure in this case. 1, 2, 3 and 4. So all these four structure, if we are visualizing over here, so they are giving rise to four different forms. So what are the name which we can give to this structure is, so it would be better if I draw them separately in the next page. So they are like this. One structure is hydrogen, hydrogen CH3 at this side, again hydrogen, hydrogen CH3, again hydrogen, hydrogen CH3, and the fourth one hydrogen, hydrogen and CH3. They are going to remain constant, and if we are having another bond, that is CH3 hydrogen, hydrogen, after rotation CH3 hydrogen, hydrogen, after rotation CH3 hydrogen and hydrogen, and the last one is going to be CH3 hydrogen and hydrogen. So we are having these four possibilities or structure we can see over here. So now if I name them like this, so this one is, you can say, fully eclipsed structure. This one is fully eclipsed structure because CH3 is at the below side of CH3, H is below side of eclipse. So this one is fully eclipsed structure. This one is fully eclipsed structure. And regarding this one is staggered. This one is staggered. But in this staggered, we are having CH3 and H. They are, you can say, in the neighboring position. So such type of conformation, when CH3 and you can say CH3, they are neighbor of each other, such structure are known as skew form or Gauche form. Skew or Gauche form. And this one is again eclipse. So this is eclipse, but here CH3 is not at the below of CH3, so that are partially eclipse. They are eclipse, but they are not fully eclipse. They are partially eclipse, or sometimes they are being termed as PE. And this one is staggered again, but these two groups are opposite to each other, so these are anti-staggered. These are anti-form, or you can say staggered form, that is in. So these are like four possibility. So we can very easily say which one is going to be more stable and which one is going to be least stable. So this one is going to be least stable, or highest energy. This one is going to be skew form, and this one is going to be most stable. Or most stable, or with a low energy, lowest energy. And these are two are the mediate one, but over here if you compare, this partially eclipse is having less energy, or you can say less stable, and this one is more stable, and this one is most stable. More stable and most stable, least stable and least stable. So energy will be like comparatively it is having a high energy, comparatively it will be having a lower energy. So if I want to give a series of this, so we can say fully eclipsed are having the highest energy, and after that we are having partially eclipsed, after that we are having skew form or Gauche form, and the last we are having you can say fully staggered or anti-form. They are having least energy. This is the way how the energy of all these form is being determined. We can see the energy of all these form are like this. So this CS3, there is some values there. So there they impart nearly 3.4. These CS3, they are creating some hindrance. So the value which they are imparting on a molecule will be nearly 3.4. And these you can say CS3 they are imparting 0.9, and this CS3 as they are imparting 1. So on the basis of that, we can calculate the exact amount of energy or stability of a compound. So on the basis of that only we have determined these values, different values of these isomers. So generally I have shown you, but one exception is there. One exception which I am going to show you over here in the case of alcohol. In the case of alcohol, what we are going to see over here, that in the alcohol, staggered form will be more stable. In the form of alcohol, we will see the staggered form will be more stable. In the case of alcohol, staggered form is going to be more stable, because we are having alcohol and alcohol, some hydrogen bonding possibility is creating over here. Over here some hydrogen bonding is there. This is more stable as compared to anti. So here this rule of this hindrance, that is not playing the role over here. In this case, the most stable is our this staggered form, which is not anti, or you can say skew or Gauche form. That is more stable, not the anti. In thus I have shown you the anti is more stable. The lowest energy or most stable is the anti form. But over here I have shown you, for the case of this alcohol, when we are having methane, ethane 1,2-diol, so staggered form is quite more stable as compared to this you can say this conformational isomers. We are seeing over here that this conformational isomer anti form is less stable as compared to the staggered form. So one more thing which we can see over here, these here we can see that I have also already I have shown you regarding those enantiomers. I have shown you this one and this one. If you visualize these two compounds, they both are conformational isomers. They both are conformational isomers, methane, ethane, propane, butane. Sorry, CS3 over here. Like this. So if you visualize this compound, so this is a mirror image of this compound. This compound and this compound, these two are mirror image of each other. These two are mirror image of each other. But the one thing which I am showing you over here is that there is no sigma or I is there, which means we cannot bisect this compound by giving us any sigma or I, which means this compound is a non-superimposable mirror image. And I have told you in the previous video that those compounds which are non-superimposable mirror image of each other, they are termed as enantiomer. So those enantiomers which are non-superimposable mirror image of each other, due to the single rotation, so they are conformational enantiomer. These are conformational enantiomers. These are conformational enantiomers. In the same way, Those stereoisomers, these can also be termed as conformational enantiomers because they are mirror image of each other, but they are, you can say, non-superimposable mirror image, giving rise to this. So a new name can be given to such compound such as conformational enantiomer. So this was like in this video we have discussed regarding conformational analysis of this butane molecule. We have already discussed these various six possibilities we try to draw, but two were quite same. So we have only selected this four structure, and we have discussed their energy, their stability, or their angles, and after that, in the lastly, I have shown you why this one NT is less stable as compared to Skew and Gauche form. This is more stable due to the presence of hydrogen bonding. And lastly, I have shown you one interesting example of conformational enantiomers. That's all for today. Thank you.